Sorry.
All right, ladies and gentlemen, section 10.5, tangent lines. Tangent lines. Lines that, boy lines that spend too much time on the beach. Common tangents are lines that are tangent to both circles here. Remember, tangent lines only touch. Tangent lines only touch the circle. If it's tangent, it's just touching, like something is tangible. Okay? Now, a secant line actually pierces it. Comes from the Latin scare, to pierce, to spear, to puncture. So, here we have tangent line and secant line. Spear. Tangent line touch, secant line spear. So we're going to start off real easy here. If you need to draw a common tangent, you're going to draw a line that's tangent to both circles. For example, this line right here is going to be touching, just touching both circles. Take a few moments here with your team or by yourself. Draw the tangent lines to those circles. Okay. All right, so the first one here, you got two lines, two circles. Got a tangent line going right in between them because they are just touching right there. Line on top, line on bottom. Here the circles are intersecting, so we got just one on the top, one on the bottom. Here we got two circles, a little bit of space in between them. Got two going in and two on the outside as well. Got one circle inside of another. They're not concentric because they don't have the same center. That's the center for one, that's the center for the other. But they are touching right there, so you got one right there. This, though, will have zero common tangents.
Because the circle is in the middle of the other circle?
If it's inside, it might be tangent to this circle, but is it going to be tangent to the other one?
No.
It's going to be secant. It might be tangent to this circle, but is it tangent to the other one?
No.
Nope. The next one. Going down to big idea number 2. If a radius and a tangent intersect, what kind of angle is that?
90.
It's 90-degree angle. It's perpendicular. Yep. So we can use this to check to see if it's tangent or not. We can use it to check to see if it's tangent, or we can just use it to, if they tell us it's tangent, we can use it to figure out missing sides. For example, up here. This is tangent to the circle. How would I find x?
What's perpendicular?
Perpendicular.
So it's 90.
So it's 90. How do I find x right here, though? It would appear I have a triangle.
Pythagorean.
Pythagorean theorem, yes. So I got to do a squared plus b squared. How much is that? 90. The radius here is 9. So guess how much that radius is? 9. X squared plus 9 squared is equal to, how much is the hypotenuse? 17. Uh, 289.
Really hard.
2 and 104, 2 and 52, 2 and 26, 2 and 13. Got a pair, got a pair. So we get 2 square root of 13. This next one's a little bit tougher, but we can still do it. 15 seconds, and I'll give you 30 seconds. Try to set this up with your team. Set this up with your team.
X squared equals X plus 5 squared. X plus 5 and parentheses. What did it do? Yeah, you did. Because the hypothesis x.
5, 4, 3, 2, 1. Who's number 10? Who's number 10? 11.
That's Lydia.
All right, ma'am. How do we set this up? Give your best shot. Okay, what's A? Or the radius is? So how much is the radius? It tells us right here. It's x, yeah. X squared plus 10 squared is equal to, how long is this whole thing? Ah! 5 plus x, yes.
That puts c squared.
Your algebra teacher would be ashamed of you. 5 plus x is 5x? My goodness. All right, so that's 5 plus x squared. Now, you may be tempted to say, oh, my algebra teacher also taught me that if it's squared, I can just square the two numbers on the inside. And you would be wrong, because you can only do that if it's multiplication. This, however, is not multiplication, it's addition, isn't it? So we have to do x plus 5 times x plus 5. And just so let's see here. X times x is x squared plus x times 5 is 5x. We have another 5x there, don't we? So 10x plus 25 x squared plus 100. Now you may be saying, oh, Mr. Kuhne, that problem's so hard, I can't do that. Oh no, Mr. Kuhne. I don't know.
How'd you get x squared plus 100?
10 squared is 100.
Oh, okay, you just brought it down, never mind. I thought you equaled that.
Wait, does that say x squared plus 10x
Plus 25. Yep. So now we have to solve it. Well, let's see here. Let's get all the x's to one side, shall we? Let's subtract x squared from both sides. What happens to that? Oh, man! That was nice, wasn't it? So 100 is equal to 10x plus 25. Can you solve the rest of that? Subtract 25 from both sides, divide by 10, x is equal to 7.5. All right, last thing we're going to have up here, if two tangent lines hit the same circle, they're the same length. Now you may not believe me, but allow me to prove it to you.
Actually, I didn't know it just worked out.
Nope. All right. If you have two rulers that are the same, you can do this pretty easily. Take your two rulers, have them start at the same spot. And if you put the ball in between, or our circle in between, and I slide it in, I look at the top, and it's like, hey, that looks like it's touching on 4 on this side. If I look at the bottom, it should be touching at 4 on the other side too. Take a few moments, play around with that, slide it in, check to make sure it's hitting the same spot on both sides. Where's your ball? Okay. So if two tangents hit the same circle, then they are congruent. We're going to prove that up here. We're going to prove that up here. So work with me here. Of course, it always comes back to triangles. So now this comes back to triangles. So we're going to prove these two triangles are congruent. Talk to me. What's one thing about these triangles that has to be congruent? Yes, ma'am.
CA and CD.
Why are they congruent?
They're both the radius of the circle.
Yep. CA congruent to CD because they are both radii. Good. You got something else?
Yeah.
What?
C and D.
C and D
CD.
is congruent to?
CD.
Oh, we got a reflective side. CD is congruent to CD by reflexive. Or you can just say because it's the same for both triangles. All right, so now we got to get a little sneaky or use something we just learned. What else? You're giving me stuff. What else up there has to be congruent? Well, we can't use AD and BD because that's what we're trying to prove. Can't use circular logic there.
Can you use the angle?
What angle?
ACD and BCD.
ACD and BCD? Well, do we have anything to prove that?
No, the other angles.
What angles?
ADC and BDC.
ADC and BDC?
I don't know, one of those.
Well, we don't know that's an angle bisector.
The other one.
This one?
Yeah.
Nope, can't do that one either. So what does that leave?
The other two.
Why is angle A going to be congruent to angle B?
How many tangents make it 90 degrees?
Yeah.
Yeah, they're tangents, so they're both 90 degrees, aren't they?
Wait, what?
What?
I'm confused.
We just learned.
Oh.
If it's a tangent line and it's a radius, they form 90 degrees, don't they?
Oh. Okay. So exciting.
Angle A and angle B are both right because the tangents are perpendicular. So angle A is congruent to angle B. That means the triangles are congruent. The triangles are going to be congruent by angle side side, right? We can't use angle side side unless we know the angle is what? Hypotenuse leg. You rock, man. Applause. Yes, hypotenuse leg. Can't use angle side side, but it's a right angle, so we use hypotenuse leg. By hypotenuse leg theorem. So then, if the triangles are congruent, that means everything's congruent, correct?
It's got like CPC.
Then AD is congruent to BD. That's the definition of congruent triangles. Throw a QED on the end.
Okay.
Yes, ma'am?
Didn't you say at the beginning of the year that we were going to get to, instead of put QED, we got to put whatever we wanted?
Yes.
What do you put then?
My symbol is QED. I suggest your symbol be W is greater than DPU. For Wabash is greater than DePaul, but you know, you can choose your own symbol. So we just showed that the triangles are congruent, which means the two tangents are congruent. So what if Mr. Kuhne said, hey, this is 3x plus 5, and this is 15. How would you solve that?
Equal each other?
Yeah, 3x plus 5 is equal to 15. And you solve for x. We're not going to do that. X plus 5 is equal to 15. You solve. So we got 3 big ideas here today. You got 2 tangent lines. They are what, everybody? They're equal. 2 tangent lines hit the same circle. They're equal. If you got a radius hitting the tangent, what kind of angle is that? It's a right angle. And we got common tangents. Those are the big ideas for today. Thank you very much.